Hey everyone, thanks for joining our webinar. And we'll just wait for some time and so that other people can also join in. And meanwhile, we have Alex, who is the speaker for this webinar. And this webinar is called Building a Full Stack Next.js AI App. Alex, do you mind sharing your screen, like so that people can see the title and everything? Hey, so yeah, in a while, Alex will be sharing his screen, and yeah, so this is what you'll be seeing, and I will be putting in the link to his notebook in the chat as well, so you can follow along in real time, and he'll actually walk you through since this is like we'll try to keep it as a hands-on session, and we'll try that everyone can match his pace, and just a reminder that you are currently in a listen only mode and there is a Q&A button that is present at the bottom of your console. And if you have any questions, any feedback, any ideas for topics that you would like to see in future sessions, if you just want to have a discussion in general, you can just use that button. And we will also be having a dedicated Q&A session that will be done by the end of the session. So if there's anything that's something that you want to bring up, feel free to communicate that using the Q&A button because we don't yeah, I see someone has raised their hand. We don't exactly take questions in that way. So, yeah, you can just use the Q&A button and we'll be very happy to answer your questions. So, let me announce first of all, I'm Yukti. I'll be your host for this webinar. So, one of my main jobs here at SingleStore is to organize these AI webinars. And we have Alex, who is a regular speaker at our webinars. And he is a growth engineer here at SingleStore. And he just graduated from Stanford. So very happy to have you here, Alex. And thanks everyone for attending. So yeah, if there's anything else that you have, just let me know using the Q&A button, and you feel free to connect with me on LinkedIn as well or Alex as well. So if there's anything that you would like to take offline, just let us know. So yeah, Alex, please take it away.
Great. Thanks, everyone. Thanks, Yukti, for the intro, and thanks, everyone, for joining me today to talk through this really exciting topic, building a full stack Next.js AI application. I know, a lot of us probably are already familiar with, the general Next.js framework and why we might want to use Next.js for our AI application. But first, I wanted to really back up and think through this concept of a real-time application, right? And why might we be concerned about making our AI applications real-time? So at a really high level, a real-time application is an application that responds to the user's inputs immediately, right? On the order of milliseconds and not seconds to minutes, right? And this applies to all aspects and all touch points of the modern SaaS application experience. Anything from viewing dashboards, viewing analytics, right, to just writing to a form, submitting a form, deleting things. Users want to use applications that move as quickly as they do, right? And with the advent of AI, with the advent of generative AI, we're seeing that users are increasingly they're building their own tiny custom applications. They're moving just a lot faster than we normally expected them to, and it's kind of imperative that our applications are able to keep up with these new users of our AI applications. Kind of one step beyond that, right? Every modern application has an underlying database, and with these new AI tools that users are now starting to learn to use and that they are applying across their workflows, a lot of these tools that we're seeing come out, Dolly, we're seeing, video understanding models come out. We're seeing audio generation models come out. We're seeing really the explosion of generative AI from just text only with ChatGPT, right, into any number of modalities that you can, of data modalities that you can imagine, right? Image, audio, video, unstructured data like PDFs, structured data like, SQL databases and, CSVs. We're seeing users that want to interact with all of these forms of data, right? And so if you have all of these needs, right, you have an application that needs to be real time. You have users that are increasingly demanding new modalities of data to be able to interact with new modalities of data, right? And your enterprise database stack kind of looks like this, where maybe you have a user that talks to the application, and then maybe your application talks to an OLTP database like Postgres. And then if you want to do analytics, you do ETL into an OLAP database, and then into your OLAP database you ingest other forms of data. You can already tell from just how kind of fragile this whole ecosystem seems that this is not something that scales for modern AI applications, right? And then obviously on top of all that, you have search needs, you have streaming needs, you have a document database, you have caching, you have a warehouse, right? And then maybe also a vector database on top of all of that, right? To manage for your infrastructure engineers to manage, for your users to kind of experience in the forms of frustrating latency and unreliability for their data pipelines and so on. Why does this actually all matter, right? This paradigm that we just talked about, right? This typical enterprise data stack is kind of widely applicable across a number of different industries, not necessarily just AI, but there's this interesting you know database, specialized database that just come out, become increasingly more popular, called the vector database, which is a solution that many enterprises are turning to now for the use of retrieval augmented generation, right? And retrieval augmented generation, for those of us that are kind of unfamiliar, is the process by which generative AI models like ChatGPT or GPT-4 retrieve private information that they were not trained on to enhance their context so that they're able to answer questions from the end user or an internal enterprise user with more factuality, with more accuracy, instead of kind of this trend that we've seen with a lot of generative AI models, where if they don't have complete information, they'll often just make things up. They'll get facts and figures wrong. They'll do this thing that we call hallucination, right? And so, at a high level, right, when enterprises maybe a year or so back started integrating retrieval augmented generation into their data stack, this is what that looks like, right? The end user would go to their generative AI application, maybe a chatbot, maybe it's an agent that they're interfacing with through the web portal, and then that question goes to first it gets into an OLTP system, then maybe you're also replicating that to an OLAP system, and then finally what you're doing is you're doing this process called vectorization or embedding to sort of tease out the meaning behind the question. You're storing that in a vector database, and finally you're passing that to your LLM so that the LLM is able to, or so that you enrich the context of the LLM and it's able to be more factual, right? And so, when confronted with this existing enterprise, AI data stack, really the question to ask yourself is, what's easier as a developer? Using an application with, all of these, OLTP and OLAP systems and search systems and caching systems that, all are connected by data pipelines that you have to maintain, that connected by transformations that you have to maintain, and adding a specialized vector database on top of it, or consolidating all of that into one single database that can handle both transactional and analytical workloads, that can handle structured and unstructured data, right? And by structured data, I'm talking about, relational queries, and unstructured data, I'm talking about, vector data, PDFs, images, audio, all of these modalities that we've talked about already. And that leads us a bit into the reason that the application that I'm going to show you all today is even possible, right? And that's because of SingleStore, right? SingleStore is a hybrid transactional and analytical database that operates on millisecond latency across any number of data types that you can throw at it. Here's just a few of them. And we combine that with powerful search and query capabilities, across vector, text, JSON data, and SQL data. We have all the kind of vector search functionalities that you would have come to become used to if you're already familiar with, semantic search and information retrieval. But you also have full text search. You have, time series search, ranking, filtering, all of those nice features that data engineers have come to expect from a modern analytical database. And so this really simplifies your retrieval augmented generation stack, your RAG stack, right? Instead of the end user prompt being written to an OLTP database and an OLAP database, and then being embedded and stored inside a vector database, that's then all finally kind of pushed into the LLM's context window. You can store all your enterprise data inside of SingleStore, right? We're integrated into the most popular embedding and generative AI frameworks like LangChain and Llama Index. So as soon as you vectorize your data, and we're actually releasing features today that let you vectorize data inside of SingleStore via scheduled jobs. As soon as you vectorize your data, all your vector data, all your structured data, all your unstructured data can sit in the same database, requiring no kind of fragile data transformations or pipelines, and really simplifying your enterprise data stack. So I wanted to show what the power of a database like this really can bring to your application. And so I built this application, which we call the real-time MBA analytics app. And what it does, and I'll show everyone in just a second, but what it does at a high level is for all the basketball fans here, it takes a given basketball game. So in our case, because we're based out of the Bay Area, we're going to look at a Warriors game, and it parses out structured information and unstructured information from the game. So it pulls out, the current score, for example, from the the game score box. It pulls out what it thinks is the current win probability of each of the respective teams, and it also uses a visual LLM running on GROQ actually to show or to give a running commentary of the events that are happening in the game. So we're combining all these different concepts that we've talked about. We're combining structured data in the form of pulling out score data from the application or from the video stream. We're combining streaming input, right? A video which is fast moving, which contains lots of different signals of information. And then we're also combining unstructured data, right? We're looking at the actions and meaning inside an image and not necessarily trying to pull out specific metrics out of the image. We're also looking at, trying to think about a win probability, right? And just to be clear, the model that does, this reasoning over the data, right, runs on, GROQ, which is an LLM provider. GROQ is really great actually because it provides models that run, on the order of 50 to 100 milliseconds instead of, a typical LLM provider like OpenAI, where if you type in to the chat box, you might expect to wait, a few seconds to even minutes, right? With their new OM models. And I bring this up, this idea of latency for GROQ inference, because, if you're using an application, or you're building an application that requires, really fast LLM intelligence, right? You're working in a space like financial services, you're working in a space like IoT or security, right? Where seconds matter, milliseconds matter. And you want an LLM to understand, sort, categorize, synthesize the, barrage of inputs data that you have coming into your business. If you need a really fast LLM to handle all of that, it does not suffice to also have, a very fragile and slow data stack underlying that LLM, because your application will only move as quickly as the kind of slowest bottleneck within your system. And so SingleStore really unlocks, applications like this, because SingleStore can, return queries on the order of 50 milliseconds instead of, 5 seconds to a minute, right? And so I just wanted to show everyone really quickly how this real-time MBA analytics application actually came together. So I'm going to pause my screen sharing really quickly here. Also, please do feel free to leave questions in the chats. I believe we do have a Q&A feature, or yeah, we do have a Q&A feature. So I will have some time at the end. Looks like we're doing pretty well on time. I will have some time at the end to get to questions. Okay, so there will not be sound for this demo, although you can imagine, the sound of the crowd cheering and the announcer talking over the basketball game here. But this is the MBA real-time analytics application, and I'll start walking everyone through it. So as everyone can see, we're starting off here with, the video playing, and I'll walk everyone through in just a second of how we actually built this application and the architecture behind the application. But as the video plays, we're getting a running commentary on this right-hand side here, this AI chat. We're seeing that, the model is able to sort of understand what's going on in the game. It's at a, because of how quickly the game is moving, obviously there's some hallucinations here, and that's why we need retrieval. But just scrolling down really quickly here, after having seen, this kind of real-time commentary, what we're seeing here is real-time analytics also running at the same time on the video stream as it's coming in. So you can see what we have here is a live polling, live refreshing set of graphs that show us, the commentaries coming in over time, the latency in milliseconds of how long each commentary takes to output, the lengths of the commentaries, and then obviously, those structured data outputs that I talked about before, the scores over time, and then also sort of a holistic win probability of both the Warriors and the Cavaliers. So so maybe we can kind of scrub through this here, and we can see that, the data is a little messy because this is a proof of concept, but the score actually updates, and these metrics actually update in real time as the video plays, right? And so, obviously, the sports analytics market and a sports analytic business is a very specific kind of use case of this. But hopefully everyone can see how this can actually extend beyond just sports into financial services, into IoT, into security, into use cases, enterprise use cases where you need to make decisions and analyze, fast moving streams of customer data, of market data, right? Of, video data or image data, right? If you have fast moving streams of data that you need to act on now, as soon as they come in, and you also need to write to this database because you have users that are interacting with your database, right? Or these streams sort of inform, uh, you know, later decisions that you make, then SingleStore is sort of your best bet. Um, and hopefully we can all see that from, running analytics on top of an application that's using a real-time data stream. So that's the demo. I'm going to now sort of move into actually looking through the code and how we actually built this. But I guess in the meantime, it doesn't look like we do have one question, and let's see, we'll see if we can tackle this before we jump into the actual code walkthrough. So Lasha asks, my main question is how best to structure the database for each specific company to ensure smooth integration and effective communication between SingleStore AI and the end user. Each company has data stored in various formats, some of which will need to be newly created. What will be the ideal structure or template for organizing this data so each company can efficiently populate a well-structured database? So great question. And this is, kind of it's a perennial question for sure. How best to structure your your data templates for storage in your actual database, right? Uh, at a high level, what you'll really want to think about is, um, you know, trying to keep your data model as consolidated and as simple as possible before adding additional columns or additional fields or properties, if you will, right? So, a recurring pattern that we see in enterprises that are trying to experiment with Gen AI use cases is they'll try to bite off more than they can chew. They'll have kind of all these aspirations around categorizing terabytes or petabytes of unstructured data and sort of understanding the entire world, right? Trying to boil the ocean. And those approaches usually fall quite flat because there are assumptions that you make in your data model. For example, if you're storing, PDFs of medical records, right? There are assumptions that you would make in creating, the columns that you would later store, values into that you won't even realize are wrong until you actually start to test these things out. So my advice would be to start simple, start with sort of what's minimally, viable, what sort of minimally shows value in the POC, and then iterating on top of that and building on top of that and adding, fields, doing migrations as you need to, as opposed to trying to kind of fit everything in all at once. But really, really good question, and happy to, kind of go into more detail if that's useful. Great. So let's see here. I'm going to pause my screen sharing again, and we'll go into a bit of the code walkthrough. Great. So I'm just going to show everyone my IDE here and sort of expand out these drop downs. So for everyone that has not gotten access to the code yet, I believe it is shared out in the chat. Yes, yeah. So it is shared out in the chat. The GitHub link is right there. That's the repository that I'll be walking everyone through today. So hopefully you're able to sort of replicate what I've done here. But at a high level, this application uses Next.js and also our SingleStore client library to interface with a SingleStore database in order to show all the functionalities that we just saw, right? So let's see. I guess the best place to start here is on our index page, right? And so for those of you that are familiar with JavaScript, this is going to be familiar. For those of you that are not, hopefully, you can kind of drop questions as we walk through this code and we can sort of understand together how this all works. So at a high level, the application, defines, a video player component, and that really kind of encapsulates, both the video and then also the kind of commentary sidebar that we have, and the analytics at the bottom, right? And so if we kind of look at the video player object, the video player component, for those of you that are kind of familiar with React, then this is going to be very familiar. But really, what the video player component does is it has, an area to play the video. What we do is we incrementally, actually, maybe this might be more useful. What we'll do is actually look at the, what we'll do is look at the architecture before we jump into the code. Okay, great. I hope everyone can see here. So at a high level, what we do is we take the video inside of the video player. We pull out frames from the video at about 1 second intervals, right? And those frames of video, we then process and then send to the GROQ API, which is the LLM inference provider that I was just talking about earlier. And that GROQ API actually gives us the live running commentary. It gives us the score tracking. It gives us the win probabilities. So both structured and unstructured data in the form of a JSON object. And then also what we do is we take the commentary snippet and we embed that with the OpenAI embedding model. And the reason we do that is because, say, for example, you want to go back later on your repository of commentary and you want to look at, all the commentary lines that talk about shooting a three-pointer or a missed shot or, a foul, right? Or all the commentaries about someone on the Warriors, or all the commentaries about someone on the Cavaliers, right? Embedding the commentary snippet with, in our case, the OpenAI embedding model allows us to do this retroactive analysis on our data. And, hopefully everyone can also extend all of this to their own business use cases, right? Being able to look back at, comments on a work item, or being able to look for, similar work that has been done in the past to be able to reference for, new workflows, for new templates, right? Then what we do is we actually, we store the frames in an S3 bucket, and that allows us to, again, go back and reference, the associated, score tracks, the win probability, and then the commentary with any given frame, so we can kind of have some observability over the process. And all of this data gets fed into SingleStore, right? So, SingleStore, which supports, vector search, full text search, hybrid search, stores the embeddings, right? The vectorized representations of our commentaries and the commentaries themselves, the score tract, the win probabilities, and so on. And all of that feeds into our application, into our live LLM chat feed, into our live analytics, and then also the historical frame analysis function. So what I am going to do here, actually, I realize I jumped the gun a little bit going right into the code. In order to run the actual code, you will, of course, need a SingleStore instance. You'll need a database. So I'd encourage everyone to go now to singlestore.com/cloud trial. And in SingleStore Cloud Trial, what you can do is you can click Start Free, and then what you can do is sign up with an account. So in my case, I'm going to sign in with my SingleStore account, and that's going to actually put me straight into the portal experience. But for a new user, you're going to see a setup process that will let you get started and create your first free starter workspace, right? We have a really amazing free tier of our databases that allows you to tinker, create, demo applications like this to really kind of spin out and test out the power of SingleStore to see if it's the right fit for your business and to see if it makes sense to migrate over to SingleStore. So once you're inside the the portal here, what you're going to want to do is actually see here. What you're going to want to do is you're going to want to create a new deployment. In my case here, I already have a shared tier workspace. But what you're going to do is you're going to click New Deployment and deploy a free tier workspace on an AWS instance. In our case, the free tier workspaces are all hosted on AWS. So what you'll do is it'll look a lot like this. I'm just going to go inside a normal space group here. You'll go into the Create Workspace wizard and then kind of select your database name. You'll select the connection details, and then what you'll get is you'll actually get a username and password, and those are both details that you'll want to make sure to save because you'll need those to access your database inside of your application. So I realize that I'm going pretty quickly through this. We're like only 30 minutes in, and I've been talking kind of continuously the entire time. So please feel free to leave questions. But once you have your username and password saved inside of after creating your first workspace and your first free tier workspace, you'll want to make sure to write that down somewhere safe. And then we can get right into the code. Great. So sort of starting back from where we left off inside of the code, we have the video player component, and hopefully now everyone's a little more oriented having seen the demo architecture. And we can see, this first section here, what it does is it hits our analytics API. So we're going to start kind of front end and go to the back end. It hits our analytics API to actually fetch the data that we need from SingleStore, sorry. And it does that at a set interval. In our case, I believe we set that at 2,000 milliseconds. So it fetches analytics data every 2 seconds. We also, we create a canvas for the video to play in. And what we do is what we do is we take the image data, right? We take the frame data from the video, and we return that frame to our commentary API, which actually handles how we talk to, both the GROQ API and the SingleStore kind of write API. So that involved, putting the image data inside of a, inside of a request or a post request, and then we write that to the API, and we'll get to that how we actually handle that on the back end in just a second. Then we have we're using a library called recharts to actually handle the charts, right? And so we define a number of different charts here. Total commentaries chart, the latencies chart, latest commentaries chart, scores over time. And I'm going to kind of speed through this because everyone has access to the code here, and I kind of went through line by line. I don't think we'd have time to get through the entirety of the demo. But we have a number of different charts here that importantly are using data in the front end, like this win probability data or this scores data that we actually pull from our analytics API. So that's where we fetch this here. And then finally, at the end, this is how we actually structure the entirety of the video player component, right? We have the video itself, we have the commentary sidebar, which we'll jump into in just a second. And then we have all of our charts. So I'm going to speed through this commentary sidebar section here because it's really just sort of a boilerplate chat window. But really what we're doing is the commentary sidebar is receiving, a new commentary from the GROQ API every time we send a frame to the GROQ API. And then what it does is it just writes that commentary to a running list of items and generates like alternating colors based on whether it's an AI message or a user message. So that's how the commentary sidebar works. And then let's see here. I do see that we got a question from Ayush who asked, will we have access to recordings in the session? Yes, you will. This session is fully recorded, and I believe it will be shared out via email to everyone after we finish up here. So not to worry if I am going a little quickly. Great, so that's how the front end works at a very high level, and then we'll kind of move into the actual backend and how we interface with SingleStore and GROQ. So in our backend here, we're actually we define a library to actually interact with the SingleStore database, and really all you need from this point is the I'll show everyone really all you need from here is in your environment file or your environment variables, you need the database host, the database username, and the database password. And the way you get that is, so I told everyone how to get the database username and password, but the way you get the database host is from inside of your deployment, you'll have a workspace connected to a database that you'll have defined. And what you'll want to do is you want to click connect next to your workspace here, click your app, and this should show you your host as well as, so your host is the string afterward, and you can change to Node.js so that it's maps more cleanly to the code that you're actually going to be using. You'll see the host, the username, and then the first time you open this window, you'll see the password, and the database name is just the database that you define as part of your free tier. Great. But anyway, going back to our code here, you'll need, again, those 4 environment variables. You'll need the host username, password, and database name. And you can see how we actually connect to the SingleStore database via SingleStore client. SingleStore client is actually, it's a really great library that we just released a few weeks ago. And it makes it very, very simple, as you can see in this example, to create or to connect and then create your first, tables inside of SingleStore, define them programmatically, write to them, and actually interact with your database. So in our case, this goes back to our earlier question about how to actually structure our data, right? Here we are actually going to structure our first table, right? And this table that I created here is actually not what the table originally looked like. As I was building out the application, I started off with just the timestamp and the commentary, right? Because it was just originally a video player that outputted commentaries that we wrote to the chat box. But as we built out the application and more fully fleshed it out, we added the embeddings and the latency and these win probabilities and the scores that the LLM is tracking, right? And that's sort of emblematic of the iterative approach that you'd want to take to your data modeling, right? Because if you start off with all of these columns off the bat, then you run into the issues of what's a meaningful default value for these columns, right? Are you going to be how are you going to migrate these columns? How might you, like, what if you wanted to, say, for example, merge the the warrior score and cavalier score down the road? That's why it makes more sense to kind of take an iterative approach to your data modeling. But anyway, this is how we kind of initialize the table. And we also, just for ease of use here, we also use or export this function that allows us to run raw queries on our SingleStore database. So this lets us actually just pass in a SQL string, and that returns, the results of our SQL query. And we do this in this case because, when I was prototyping this application, it was much faster to write out the raw queries. But SingleStore client, if you kind of look at the documentation for it, and I'll actually do what I'll do is I'll send out the SingleStore client documentation in the chat for everyone to look at. If everyone takes a look at the SingleStore client documentation, it's actually much more. There's many more features than I can cover in this webinar today, and it actually allows you to do programmatic selects and joins and filtering. But for the sake of simplicity today, I'll be running just raw SQL queries on the SingleStore database. Great. So we have this table created with all these columns, and especially these commentary, embedding, latency, win probability, these columns that we are actually generating, parsing from the video data, right? And the way that we do that is we actually use a vision LLM, right? And a vision LLM is different from a normal text-based LLM because it has vision, right? And in this case, what we're using is we're using the GROQ, and I'll also share out the GROQ URL to everyone. We're using, in this case, the GROQ Inference API to actually perform the task of parsing out the information from the video frames in, not seconds like you might expect if you gave an image to, GPT-4o, for example, but in milliseconds, 100 seconds to 200 milliseconds, right? And so the way we do that, this is a little bit more esoteric, but the way we do that at a high level is we we connect to the single store database because we need to write the data that GROQ returns to us inside of SingleStore. And so we initialize our commentary table from our SingleStore client. And then what we do is we create a chat completion, right? And so this is really the meat of it. We kind of pretend to be a user and we tell GROQ, hey, I'm going to give you this image, right? And I'll talk about in a bit about how we actually encode the image, but I'm going to give you an image, and then I'm going to kind of describe at a high level what that image looks like. And then I want you to actually return a JSON object with this schema, right? I want you to return a JSON object with, a commentary string, win probability string, the current score that you see in the score box. And then I'm also going to, populate the latency, right? I want you to populate the latency. And so then GROQ actually comes back to us. And what we do is we parse out the data that GROQ returns to us in the JSON object using the JSON library. And then we take that data and we can write it. We take that data, we generate an embedding with OpenAI, and then we can write it into SingleStore. So I'm going to back up a little bit and cover a few holes that that we ran into here. First is how do we actually encode this image, right? And the way that we do that is inside of this frame processor library. And that's going to, we actually call this process frame function, I believe, inside of video player. Where is this? So we send the frame data to our commentary API, and then that actually calls our process frame data. So that call, once we send the frame data to our commentary API, we generate the commentary, and this is this is proof of concept code. So I would probably simplify this for an actual enterprise application, but we generate commentary, then we actually go to GROQ with our image. And then inside of our generate commentary function, inside of our commentary generator library, and happy to jump into more detail of why we made the decisions that we did. We actually call this process frame function, which this is a lot of code, but importantly, what it does is it converts our frame into a base 64 structured string, or base 64 format string, sorry. And that's the format that GROQ can actually read our frames. Anyway, that is, I'm realizing now that we only have 10 minutes left. So that's at a very high level, how this entire application kind of comes together. There's a few features that we didn't manage to get into, like semantic search and storing the frames in AWS. But at a high level, what we're doing is we take video frames, we send them to the GROQ API, which returns both structured and unstructured data to us. We convert, these commentary strings into embeddings, and then we store all of that into SingleStore. And then what we actually do, this is one last very important piece. after we've stored the actual data inside of SingleStore, we can actually run analytics on the data in SingleStore, and that's what powers the graphs. And you can see the SQL queries that we run on the analytics data in SingleStore that we run, about every 2 seconds inside of the application. And you can see that, if you actually look at the speed that the queries are running at, they're actually running much quicker than 2 seconds. The reason that we set it at 2 seconds is the SingleStore API returns these queries in the order of 50 to 100 milliseconds. But we were actually running this application on the free tier of the GROQ API, and that actually limits you to about 2 seconds or a query every 2 seconds. So that's the reason that we limit the polling rate for that there. But these are the queries that we actually run to return data that we then read into our graphs. And that's the analytics data that we end up returning to the front end so that the graphs can show the results to the end user. Great. So that was a lot, I know. And I wanted to take some time to look at questions before we wrapped up. So let's see. So Zia asks potential use cases in emergency care and triaging care. So definitely yes. Especially in healthcare, traditional databases that healthcare systems use are often, OLTP systems that are not well suited for, analytical workloads that, healthcare system administrators may need to run in order to understand, at a kind of aggregate level, how their, emergency rooms are running, how their, what the metrics look like on different rooms and beds and that sort of thing. So definitely use cases inside of emergency care, triaging care, and healthcare in general. Let's see. Mahmoud asks, I'm assuming we're using a vector database. Good question. We are using SingleStore, which is a vector-capable database, but it is not actually a specialized vector-only database like Pinecone or Chroma or Weaviate, for example. Not to say that those specialized databases don't have their use cases. They definitely do in sort of more proof of concept applications. But for enterprise applications, what we're really seeing from our customers like Apple, like Goldman Sachs, like Morgan Stanley, is a need to consolidate, siloed data across different, vector databases, analytical databases, and transactional databases into a single database. So very long way of saying we are using a vector capable database and not a specialized vector database. So Risha asks, how are video frames extracted and where are they stored? So Risha, I believe you asked this while I was kind of walking through the process of kind of how the video frames are actually extracted, and then how we actually pass them to the GROQ API. So hopefully that was helpful, but happy to kind of dive into more detail. Or feel free to review the recording of this webinar after we finish up. So Mahmoud asks, how would something like this be used for mining and petroleum use cases? Could it, and is it used to assist in drilling applications? And how could something like this help with autonomous applications like safety valves? Really good question. I will say that I am unfortunately not an expert in mining and petroleum use cases. I can sort of brainstorm at a high level how this might be useful. The things that jump out immediately to me are, for someone that is monitoring the overall health of an entire mining or drilling operation, right? It's very important, I would imagine, to them to understand if there are anomalies in the health of any specific drill or any specific, kind of machine in the system. And if these drills or these machines output signals, right? They output logs that write to a database, then that can be written into SingleStore, as quickly as, and then as quickly as those, you know, signals, logs, metrics are written into SingleStore, you can understand immediately, on the order of 50 to 100 milliseconds again, what is going on in your system and act quickly and decisively in case, um, for example, a drill has failed or is in an unhealthy state or something like that, right? So I don't know off the top of my head if we have any clients that are in mining and petroleum use cases, but Mahmoud, really good question, and happy to. I'll actually leave my email here. Happy to uh, chat further if we could be of any help in seeing and exploring if SingleStore works for your specific use case. Great. Let's see. It looks like in the chat we have the SingleStore client link. So Sangeeta asks in the chat, only the SingleStore client link is provided. Can you provide a link for this Word commentary API? So I believe I will send this out again. I believe Yukti did share this out at the start of the webinar, but it might not have shared out for people that joined a little later. So I will just share this out again. All right, that is the Warrior Commentary API link. Please feel free to use the code, and if you do have any questions, please do send me an email. Great, I think we are coming up on time here. Yukti, do you want to wrap us up?
All right. So, if there's any other questions, you guys can reach out to us at team@singlestore.com, or maybe, oh, Alex, you sent some stuff, and that's to hosts and panelists. So actually, this setting is like for it's just default. So whenever the speaker sends something, it's always
Oh,
sent to
oops.
hosts and
Yeah,
yeah,
good
I mean,
catch.
I've sent it too. So yeah, you can find Alex's email ID as well. And I did respond to someone with my own email ID as well. They were suggesting some ideas for future webinars. So I have a question from Talha Khan. They say that is there any limit for video size?
Is there any limit for video size? So in principle, no. But the concern that I would have with a very, very long video is there's this phenomenon that we've run into with LLMs where the longer the kind of conversation that we have with them, the more unreliable they tend to be. We're not quite sure why this happens, but um, and obviously performance needs vary from enterprise to enterprise, but that's the one thing that I would caution. There's no limit on video size that you can use in this application specifically, that where you're sending frames to an LLM and you're having a conversation about that, but that's what I would be concerned about.
All right, so I hope that answers the question. So, if there's any other questions that you felt like was not answered, like again, you can just reach out to us and just let us know, because uh, it's our company guideline to actually answer 100% of the audience questions, like whatever is there. So feel free to let us know. And thanks for attending. We actually have amazing sessions that are coming up. So just give me a second. Let me pull that out for you, and then we can conclude the session. Yeah, so we are presenting how to build local LLM apps with Olama and SingleStore for Mac security, and that's on November 13th. And we are presenting one more webinar with Professor Tom Ye again. It's called Building a Vector Database in Excel. So he has this very innovative way of doing webinars. Like I'm talking about Mr. Tom. So he uses actual pen and paper to actually teach code. So that's really interesting. So if any of these topics are interesting to you, feel free to RSVP right now. These topics will be sent to you via email in the follow-up email for this particular webinar. So yeah, if you're interested, feel free to RSVP, and I hope to see you all there. And thanks for attending today's session, Alex. Thank you so much for this amazing session that you gave. So yeah. I hope to see you all again, and I have a great rest of the day. Take care, everyone. Bye bye.
Thanks, everyone.